We already done with the bacteriology, and then we will go for other very important and big topic that summarize the virology. I know there are a lot of people, they already spend decades and spend all of their lives only for focusing on the virusology. So I would to summarize it and make it easy for you so we can absorb it and utilize this information for our course. This is Abdul Karim Blasi. Enjoy this session.
Virology, a basic introduction for infection control. Let's make some agreements about the kind of this concept that, as we described before, the virology is a very big concept, and we would like here to summarize the most important aspects for us and what are the key features that we should work on it until we are able to perform a proper understanding and utilization of this information for us. Let's first start to describe the viruses. It's simple, but at the same time, it's a complex feature. There are a few questions that come from the experts when they start to describe the virology, which is the dilemma about the life. What is the life, and how we can describe features or organ as a live condition or a live feature? What are the characteristics that we should have it until we say, yes, this is live organ? There are several theories describe the origins of viruses in the earth or on the earth. As we can see here that within the description of the biology among the natural selection and evolution theory, Darwinism, that there are still debate on how and when the viruses already appear on the life. The first hypothesis, which called the progressive hypothesis or escape hypothesis, suggests that viruses originated from genetic material, like it's originally come from DNA or RNA, and this DNA or RNA escaped from cells. This material even evolved the ability of infect cells and replicates. This is why the virus able to come to the cell, because originally, between quotation, it's already escaped from the cells. This hypothesis also contradicted by another hypothesis, the second hypothesis for the development of the viruses, which is regressive hypothesis or reduction hypothesis, which proposed that viruses were one complex small cells that using or doing the parasiting or parasized, they are living on or living inside large cells. However, over time, the evolution happened or the natural selection happened, and these cellular organisms lost their ability to live alone and start to be totally independent on this kind of cell, eventually evolving into simple virus-like entities. The third hypothesis for developing the viruses, which is the virus first hypothesis, suggests that viruses predate cellular life, and this is the only theory that describes the viruses can be older than other features of the life or other cellular formation. In this view, viruses could have contributed to the development of cells rather than the other way around. Anyway, within all of these three theories or three hypotheses to describe the originality of the viruses, we come to know that viruses within its feature, it's much simple and more complex than the other cells, because it cannot replicate alone. It's just a DNA covered by protein, but it develops long way of injecting this DNA inside the cells to produce the disease and making this kind of life features. We can see here the size of the viruses. We are talking about very small entities. Look for the photo here that we're describing that the smallest or one of the small viruses in comparing to bacteria. So it's almost on the size of the bacterial ribosomes, and this is the biggest virus, smallpox virus, and this is in comparing to the bacteria. So you can see how much the size of the virus in comparing to the bacteria. And look here for the size of the bacteria and comparing to the RBC. So you can see how much the difference is happening between these two features, and how much we're talking about very small entities for the bacteria. When we are looking here to describe what's going on within this part, you can see that the size of the viruses, we are talking about, for example, the Delta viruses, 1.7 multiplied by 10 power 3. And when we talk about human cells, we are talking about 3 multiplied by 10 power 9. So we're talking about more 6 zeros coming inside just only to describe the size of the genome for the cells. So this is how much the complexity or the difference in the size. Within this category, we can describe the need for how we will classify these viruses, how we will categorize it. And this is what we will discuss in the coming lecture about viral classification and taxonomy.